How many of you have applications that require enterprise end users to log in? Quite a few. How many of you are using WebView to help accomplish that? All right, this session is for you especially. I'm Andy Smolik. I am ecosystem cat herder on the Android team. I work with a lot of different Android for Work ecosystem partners. And I also work very closely with the identity team at Google. And so I'm going to let William introduce himself and kick this off.
Hi, everyone. So I'm William Dennis, product manager on the identity team. And one of the goals of identity at Google is to build a kind of consistent model of the user and their devices and use that so that we don't have to re-authenticate them quite as frequently. You may notice that the Google session on your Android device has an incredibly long-lived session. And you almost never have to re-authenticate to Google if you need to sign into something like, say, Stack Overflow. And that's a result of the efforts that the identity team have been working on. And so with the consumer use cases fairly well under control, we're now turning a bit of attention to the enterprise use cases to see what we can do to improve the user experience there. Right, so the typical enterprise user will see a login screen like these several times, or fairly frequently. And they'll need to sign in with the same credentials, typically their corporate credentials, into each of those apps. And quite often these apps are using WebView as a way to extract the difficulty of integrating with a lot of different IDPs.
Identity provider, for those of you that aren't identity guys yet.
Yes, thank you. And yeah, so using the WebView, the user will log in with their same corporate credentials, but they'll be doing it multiple times. And what I don't like about that is that, to me, it doesn't really provide single sign-on, or at least not the user-friendly definition of single sign-on, which I prefer to use. And that is that the user only signs in once, as opposed to the alternative definition of single sign-on, where the user is signing on multiple times but using the same credentials. So certainly that is still better than what came before, but I think we can do better still. The other problem with using WebView for all this is that there's not a great security model in that the host app can actually extract the cookies or inject JavaScript and do basically whatever it wants. And this basically violates the principle of least privilege because the host app is getting a more powerful credential than what it really needs. And you may be thinking, well, that's not a problem for me because I trust my developers. They're not going to be stealing the cookies. They're not going to be injecting any JavaScript. And that is certainly true for a lot of people. We have these enterprise contracts and developers get paid and then no one's trying to do anything bad. But we've actually seen in the wild a few times where an honest developer has inadvertently run into problems just by including a third-party SDK. And the problem here is that any of the third-party SDKs that they include could be doing something bad as well. And so that trust necessarily goes to every single SDK that they're using. And the other thing is maybe you do have some less trusted developers, and maybe you don't want to have to audit every single line of code in your app. So this model does suffer a few security problems using WebView. So now Andy's going to talk about a new feature in Android that looks like it could be set to replace WebView as the way to get people signed in.
And one of the things that we want to reinforce throughout this session is we're not talking about Google Identity here, although it works with Google Identity. This has nothing to do with using Google Identity in your SaaS service or your SaaS app or signing on an enterprise user with a Google Identity. Everything that we're going to show you is going to work with standard OAuth and standard OpenID Connect, and we'll get into more details here. But what I want to start with is what's a custom tab and why should you care about using a custom tab when you're doing a sign-in? First of all, you'll notice that what we've got here is at the very top.
Middle button.
Middle button, all right. At the very top, you have an address bar. That address bar is locked. So the user can see where they're going, but they can't change the destination, okay? The other thing here is everything that you see inside here makes use of what's already existing in the shared cookie jar in the Chrome system browser, right? So what you're going to see is completely reflected by the content. You'll see this in the demos that we do. The cookie state is something you can take advantage of. That's not something you can do with a web view. And then the last and most important thing is this is not requiring an app flip to get to Chrome. It's an activity that shows up within the native application. So there's a particular Android API even for this that works. There's a support library, literally goes all the way back to Android 1.6. So let's suppose that you happen to be the developer of a alternative non-Chrome browser. Well, guess what? You can do exactly this same capability and do custom tab for developers to use and go all the way back to older versions of Android and still get this capability. So there's an example implementation here, there's an example client, and basically this is everything you need. Let's say if you're an OEM and you've got your own web app that's delivered as part of your phone, you can use these to get the same capabilities. So Chrome Custom Tabs came out in Chrome 45. There's a few versions back now. You've probably seen it in applications where instead of using WebView, you're now seeing something that actually knows your authentication state or knows who you are when you come in. In many cases, it wasn't done for authentication purposes. It was done so that the user experience was a little bit cleaner. Now, the great thing about this, oh, there we go. Take a look at how much faster Chrome Custom Tabs are than either WebView or the system browser, right? Even if you just wanted to improve the performance, the rendering performance of what's happening, Chrome Custom Tabs are an awesome solution. And there's great videos on there for app developers that want to use Chrome Custom Tabs for other things as well. But the important takeaway here for our purposes today is they're fast, they're secure, and they go all the way back to versions of Android that are actually we'll get into a little bit more. Basically, Jelly Bean and beyond is supported specifically by the version of Chrome 45 that we'll be making use of.
Cool. So let's talk about how we can use this new Android feature to improve the authentication experience for our users. And you'll probably notice that I've put an iOS screen here as well. So everything I'm about to talk about actually works on both Android and iOS, although we'll be mostly showing the Android demos in this talk. But that's good news if you're a developer, because one of the hardest things about Auth is if you're dealing with a lot of different authorization servers or a lot of different identity providers, you don't really want to have to convince everybody to make a change. And so the good thing here is that regardless of what platform your apps are on, you can use the same pattern and you won't have to kind of go to the same identity providers twice. So let me run a quick video of what the end user experience will look like. Okay, so for this example app, the user is signing in using Ping Federate as their authentication server. And the app has just launched Chrome Custom Tab with an OAuth 2 authorization request. And in this case, the user does need to re-authenticate, but you will notice that the username was already there, probably from a previous authentication. Once the user authenticates, they can then approve the request, and the OAuth authorization code is returned to the app via an intent. The app can exchange that for the access token and make an API call. All right, so we're just going to clear out the data here of the app to simulate the user using a second app and take a look at what that experience is going to be. So the second time the user logs into a different app, you'll notice that they're already authenticated, and that's due to the shared cookie state with Chrome. So it's a simple tap, no password, no re-authentication. They can get back in, and we can make that API call. So that was Ping Federate as an authorization server. Now let's try Google. Basically, it's the same approach. The user's already signed in thanks to the account on the Android device. We can approve the request, get the authorization code, exchange that for an access token, and make an API call. All right, what about something a little bit more complicated? So here we're going to open ping feder again, but this time we're going to actually chain the authorization and use a different authentication provider, in this case Google. And so ping fed has actually redirected to Google to do the authentication, which then responds. The user then approves the request, and they're done. For completeness, let's run this again, clearing out the app data. So again, we open the OAuth 2 authorization request to ping fed, but because we have the saved cookie state, it knew it was already using Google, so it's redirected straight away. Users accepted the request, and we're good. All right, so what just happened? Basically, the first time the user needs to log in, they'll get the same login screen that they're used to, and they'll sign in once. But then on subsequent apps that the user installs, they don't need to repeat that sign-on. And if you're dealing with a re-authentication environment, something where you have like a short-lived session, maybe it's a day, hopefully it's longer, but the good news there is that even in that case, the user is still only re-authenticating once. They don't have to keep doing that for every app that they use. And those more complex chained auth scenarios work as well. And we see these quite a lot where you have various different bits of middleware all doing their own thing. As far as the app is concerned, all it really knows is that it's talking OAuth 2. It's opening a request and it's waiting for an intent. And everything else that happens in the middle is actually just handled by the browser and in Chrome. So the sky's the limit on what you can do in the middle there. You can use second factor, or you can redirect anywhere you want. And this pattern works with any authorization server that supports native apps. And I'll go into a little bit more detail about what that actually means in the next couple of slides. Let's look at some sequence diagrams. So this is the sequence diagram for a typical SaaS app. And you'll see that an optional step here, you can use the tools that others have been talking about today to push a managed configuration to the SaaS app. And you can provide things like the tenant hint or the user hint in that configuration.
We should point out that's optional.
Yes. And the SaaS app then does an OAuth request to the SaaS backend. From that point on, it's effectively a black box as far as the app developer is concerned. And the SaaS backend will then typically redirect to an enterprise authorization server, perform whatever it needs to do, before responding with an OAuth response. The IT app case is fairly similar, just a little bit simpler, because the IT app only has to talk to one IDP, one identity provider. It can just load the OAuth request directly to its authorization server, and again, you have that same black box.
And typically, the developer in this case will be hard coding the identity provider within their app because there's only one.
Right.
In the SaaS case, the SaaS developer has got to deal with an arbitrary number, and those specific identity providers won't even be known to the app beforehand, but the SaaS service backend will know.
Right. And so I talked about this black box of like the app doesn't really know what's happening in that authorization happening in the Chrome custom tab. And one of the cool things is that because it's a real browser, you get every feature that the real browser has, such as mutual TLS. So if you're an EMM, you can basically push that TLS certificate to the browser, and the app can take advantage of it without the certificate actually needing to be pushed to the app. And I think that's a really big advantage, because previously you may have to push that certificate to every single one of the apps, and the apps will have to understand it as well. And if that's only like one or two customers, it can be a lot of work and hard to justify. But this way, because it is a black box as far as the app is concerned, you can build in all these additional authentication things in that black box. And we actually discovered something pretty cool yesterday, which is that FIDO, if you've heard of FIDO, the U2F standard can also work inside this custom tab black box as well. So really, there are a lot of cool things you can do.
Before we switch, I want to point out, if it's an end device, the end user doesn't even have to deal with this dialog to be able to get that certificate bound up within it.
Good point. Thank you. Makes for a good screenshot, though, I guess. All right, so in terms of support, as Andy mentioned, the custom tab itself is available, I think, back to Android 1.6, but Chrome shipped that in Chrome 45, which is present on about 95% of devices. And the story for iOS is pretty good as well. The important thing to note is that even though there is a small percentage of users that may not get the custom tab, there is a universal fallback, which is that we can simply just open the browser, the full browser, with that exact same authorization request and wait for the exact same intent coming back. So 100% of users are supported. It's just that, say, 95% get the sort of improved experience. All right, so how do we help you actually implement this? Well, to start with, we have a draft best current practice going through the IETF OAuth working group right now. I'm a co-author of the draft, along with John Bradley, who's in the audience today. And this best practice details how you can, as a relying party or as an identity provider, implement this best practice and do it correctly and securely.
It's important to point out this has been accepted by the OAuth working group as an official working group item. So
right.
this is not just two guys writing a draft. This is actually the OAuth working group taking this up, and we'll be publishing this as a BCP.
Hopefully we'll get it out sometime later this year. And so what are the requirements for an authorization server? Well, it's sort of three main points here. The first is don't assume that the client can keep a secret. Now, this is probably an assumption that you're not making if you're doing any kind of app authentication today, so that one's probably pretty easy. The second is that you need to support custom URI schemes for the OAuth redirect. Now, the OAuth spec itself actually just defines the redirect URI as a URI, which could be use any scheme. But a lot of people, when they implemented it, they sort of assumed that there was an HTTPS redirect scheme. So in some cases, you may need to do a little bit of work on the authorization server just to relax that requirement a little bit and allow for any arbitrary scheme for the redirect. And finally, something that we recommend is that you support PXE, which is called the proof key for code exchange. And that just adds a little bit of extra protection in this inter-app communication environment where we're using intents and there's a potential for things to get intercepted. It's a fairly lightweight extension to OAuth. All right, if you're an app developer, we have even better news for you because the teams at Google have actually contributed a reference library to the OpenAI Foundation, which we call OAuth. And this reference library is available on Android and iOS, and it completely implements the best practice specification. So it'll handle the authorization request, it'll add in PXE, it'll do everything correctly. And one of the real benefits of actually having our team provide this code, particularly on Android, is that we've taken care of some of the complexities of using a browser to do this type of flow. So for example, we're going to check the system to see if the user has, if their default browser has custom tab support. And if it doesn't, then we'll look for any browser has custom tab support. And if there are none, then we look at, down the list basically until we find a suitable user agent to load the request in. And there is a production example. So Google on iOS is a third party, just like many of you are a third party on Android. And so we follow this best practice for our own sign-in API on iOS. And I think Facebook is doing something similar as well. So if you want to see some examples of this actually in production, there's a couple today. And let's talk a bit about the implementation.
We mentioned earlier that it's optional to use managed configuration here. Let me explain how that's done and why that's done. First of all, you're probably used to, when you're signing into a SaaS app, putting your email address in first, sometimes putting your password in on the same page. But you've noticed that recently, a lot of SaaS developers have started doing what we call tenant discovery by taking your email address first before you provide any password, right? So that's how the SaaS backend, the SaaS app and the SaaS backend figure out which identity provider to go to. Well, the great thing about managed configuration is you can, using the EMM, using the configuration that for a given enterprise customer, already tell which backend, which tenant, which IDP should be hit. And in many cases, you're also going to be able to tell what the username should be. In fact, in many cases, it's valuable for the enterprise to be able to specify the exact account that should be used. And the great thing about this is when you do that, you can go right to the password as the very first screen that the user sees managed configuration could even send the password too, but we don't recommend that. That's certainly not a very good security best practice. But the point is, you can make it so that the only thing the user has to do after they click on that app is put their password in for the very first time. Every subsequent app that uses that same identity provider, the next time that the user clicks on another app, it goes straight in. It's been completely provisioned. The user hasn't even had to put anything in, right? So managed configuration, you start with the developer defining in that, in their manifest, what those app restrictions are, right? The admin on the EMM console figures out what specific configuration to send for that app using managed configuration. The device policy controller is the one that actually sends that down, or as you saw with Play going forward, you're going to be able to do that through Play. And then the app receives that information and goes straight to the information that they need. So these are the specific APIs. None of this is particularly new. This has been here since Lollipop. But you can now use that to tee up and take full advantage of OAuth for single sign-in.
All right, speaking of OAuth, let's go through a brief code example of how you would actually use OAuth in your app today. So the first thing that you need to do is spin up a configuration object, supplying the authorization and the token endpoints. Or if the identity provider supports dynamic discovery, there's a way you can do that too. Next, you build the OAuth request, specifying what scopes you need. In this case, we're just looking for the identity scopes of the user's profile and email address. And then finally, you send that request that you built to OAuth, and it will load up the Chrome custom tab or fall back to the default browser if Chrome custom tabs isn't ready. Next, to actually get that OAuth authorization code coming back to the app, you need to listen for the intent, which is your redirect URI. And so you'll need to edit the app manifest and add a new intent filter there to watch for your redirect scheme. And since we're talking about redirect schemes, let me talk briefly about what you should do to pick a good URI scheme here. And what we recommend is using a collision-resistant URI scheme. So something like using a reverse DNS style. So something like com.yourcompany.yourapp would be a good choice, because what it means is that no other app is going to accidentally pick that same scheme, at least not in an honest way. And you should avoid things like app or generic words, because there could be inadvertent collisions. And you may be thinking, well, that malicious app could actually just register my scheme anyway. And that is certainly true, which is why on the previous slide I recommended that the authorization server should support that PKCE specification, which mitigates that problem. Okay, so once you've registered that intent in your app's manifest, then you receive that intent and you pass that on to the library, which will analyze the URL and extract out the authorization code, at which point you exchange the authorization code for a refresh token, access token, and an ID token. And then finally, you can make an API call with that access token. And OAuth also provides a convenient API here where you can just wrap up your API call and we'll take care of the token freshness for you. So if the access token has expired, we will hit the token endpoint, refresh that token, and then call your API call with that fresh token or with an error if an error occurred. So that's just a brief demo of using OAuth. I highly encourage you to visit the GitHub repository, download the sample, and give it a try. If you have any questions or comments, please file an issue in the GitHub. The team is very responsive. We're always looking at those, and so we'll definitely fix any problems that you find. And with that, I think we...
Yeah, I should mention a couple of things, because we've gone through so much material, and what a lot of people may not recognize, this is a problem that we've had with native mobile apps on all platforms for years.
Right.
And it's only recently that Android's Chrome Custom Tabs on iOS 9 Safari View Controller provided kind of a roadmap to go do this. But this reference library is really what's new, right? Does everyone have to use the reference library as it is? No. They can go and they can fork the GitHub and make it so that it works better with their authentication scheme. Is this a Google identity solution? No, this works with any standard. Really, the patterns that you see with web SSO apps with web browsers today, we're just replicating those here so that they work better with native apps.
So that demo that I showed earlier actually was built with OAuth, and as you saw, used Ping Federate, which is a third-party enterprise identity provider. So, yeah.
Great. Let's take some questions. We've got a few minutes.
Hi. The name, Chrome Custom Tabs, I find that a little confusing. Can you give a little background about why that's the name? And
sure.
Do you feel it's descriptive of what it is? And if not, what would you call it?
So there's Custom Tabs, which is an Android thing. Chrome was the first system browser to implement Custom Tabs APIs. And so when you use what's in every phone that is launched with Google services on it, you're guaranteed to at least have Chrome Custom Tabs available to you as a developer. So Chrome Custom Tabs, well, let me explain the concept of Custom Tabs. The idea with Custom Tabs is you're an app developer, you want to be able to show some website, or in many cases it's kind of social use cases, where the idea was let's make it easier for developers to access things that are in the cookie jar so that they can have more context in these social sites, right? It turns out that it's also really good for authentication. So Custom Tabs is an improvement on web views that gives you access to the cookie jar and gives you as a developer a whole bunch of cool things. Chrome Custom Tabs is a Chrome implementation of that. Like I say, if you're a browser developer, you can have your own Custom Tabs as well.
And I guess regarding the name, I don't know who came up with the name. I think the idea is that it's a custom tab running inside the app. The app can actually change the color. They can put an icon there. They can put an action button. So I think we had one slide there a while back where Pinterest could put like a pin it button. And so I guess like those are the customization options that you have, and perhaps that explains the name. When it comes to kind of the generic pattern and in the spec, I actually refer to it as like an in-app browser tab as like a generic way to refer to the feature on both iOS and Android. So
I suppose it's worth pointing out that our full session name is using OAuth for SSO with Chrome Custom Tabs. Kind of got shortened to Chrome Custom Tabs, but it's OAuth that we are specifically promoting here.
Yeah, and the pattern behind OAuth, yeah.
Right, exactly. The web pattern, which previously you had to use a proprietary SDK from an identity provider to do anything similar.
Maybe time for one more.
One more?
Well, I feel bad if I asked the wrong question. So out of curiosity, so what makes Custom Tab faster than the standalone Chrome browser? I mean, anything you can share? Why?
Right, so that's this one here.
Yes.
My theory is that switching to the actual browser just incurs a switching cost. Like there's time to, yep.
Here we go, hold on.
So yeah, so Chrome Custom Tabs have a few features that allow you to preload the web page before you switch context, and that allows you to have the resources ready. There's warm-up features essentially.
That's a really good point.
Yeah, and so that's why you get that faster switching.
That's a really good point, yeah. So the app can basically like warm up that authorization request, have it ready to go.
All right, I'm gonna take one more small question.
Very small question. So the Google login page was using a web view, and is that when it's going to switch to using custom tabs?
So we are looking at various things like that. Google is kind of special on Android because we're a first party, so a lot of the things I said about WebView being problematic is not actually true if you control the platform end to end, because obviously that you trust yourself. But we are always looking at various things and to look where we can improve.